Good afternoon. Today is Monday, October the 26th. Today in geometry, we looked at a couple of problems dealing with distance between a point and a line, and also distance between two parallel lines. I will go over the example that's in your book on page 215, dealing with how to find the distance between a point and a line, and then you can look at the example on page 217 to find out how to find the distance between two parallel lines. So I'll share my screen here and we'll get to work on this problem. So when you're looking at finding the distance between a line, say we have a line here and a point. So we'll put our point up here now. So you get two sets of coordinates on the point, on the line. So this coordinate here will be -5 and 3. -5 and 3. And we get a second point down here on the line, which will be 4 and -6. And then the point we're interested in up here is the point 2, 4. So we're trying to find the distance between this point and the line shown here. Now this distance is going to be a perpendicular distance. So if we look, it will be the distance that comes from this point down to the line here in a perpendicular fashion. And that's the key to the problem, because when we find the slope of this original line here, then we can use the perpendicular techniques to find the slope of this line. So step one here is to, if we do step one, is to find the slope of this line. So when we use our slope formula, which is m equals, and we got y2, which is 3, minus a -6, which makes it 3 plus 6, divided by x2, which is -5 minus 4. So this ends up giving us a slope of -1. So the line here has a slope of -1, and we can write that down here. The slope here equals -1. So if you remember from perpendicular lines, that means the slope of this line is the negative reciprocal. So the slope of this line is going to be equal to 1. Now, so step 2, so we'll go back to text here. So step 2 is to write the equation of this original line, and we can do that using the slope-intercept form, or the point-slope form rather. So we do y minus y1, and in this case, y1 can be 3, okay, equals the slope, which is -1 times x minus x1, so minus and minus is going to make that x plus 5. And if we solve this, we come down here and we get y equals minus x minus 5 plus 3 is going to be -2. So now that's the equation of the original line. Now, step 3 here is to find the equation of this perpendicular line that goes through 2, 4 with a slope of 1. So we also use our point slope formula here. So we have y minus 4 equals the slope, which is 1. Then we have x minus 2. And if we solve this, we get y equals x minus 2 plus 4, which is plus 2. Now, step 4 is to set these two equations that we have in step 2 and step 3 here equal to each other. So we have minus x minus 2 equals x plus 2. And if we solve this, we get 2x equals 4, or 2x equals minus 4. So x equals minus 2. Now, if we take that x equals minus 2 and stick it into either one of these two equations up here, we'll get a corresponding value of y equals 0. So what we have now, if we come back to our drawing here, we have determined that this point right here has a set of coordinates which are minus 2 and 0. So now we can come back over here and we can do step 5, which is to use the distance formula and find the distance between these 2 points. So we have, I will go ahead and write this out, the distance equals, and I'll put the square root symbol on in a second, but we can do parentheses, and we can do y2 or x2, which is 2, minus a minus 2, which is going to be, I want to put it there, put it in here. Okay, so we have 2 minus a minus 2, which is 2 plus 2. And remember, housetop is squared. Okay, plus y2, which is 4, plus y2, which is 4, minus y1, which is 0. Close that and square it. And then we take the square root, which would be the 1/2 power. So that's going to be 0.5 power. So now we're going to take the square root. So if we come down here, you'll notice we get d equals the square root. So I'm going to put that, and we've got 4 squared, which is 16, plus 4 squared, which is another 16. And we're raising that to the 1/2 power, so 0.5 power, and that gives us the square root of 32. So 32 to the 0.5 power, which simplifies to 4 times the square root of 5. 4 times the square root of 2. Okay, so that's 2 to the 0.5 power. So now that's one of the two major problems that we looked at today. It's a fairly key concept in more advanced geometry, being able to find the distance between a given line and a given point. So now I will stop sharing here. If you will look on page 217 in your textbook, you can see the example problem which shows you how to find the distance between 2 parallel lines. It's very similar, so look at it. If you have any questions, let me know. Now, in the in-class group, we'll be taking a test on Chapter 3 on Friday. I will post your test requirement on Wednesday so you can start working that and then get it back to me by Friday at the latest. If you have any questions, send me an email and I'll get back to you.